Well, hi, good morning, and thank you so much for joining me in my shop here on July, July 14th for another couple capacitors here. Now, I've gotten off to a late start this morning, so I may only get one done. But let's really start off with something a little different here. In the last video, it says a pictorial history of radio in Canada. I mentioned a certain individual who I think is a very important Canadian historical figure when it comes to radio development. In fact, he really should be an internationally known. See what it says on the bottom of the picture? Unsung hero. Reginald Fessenden, the Canadian inventor of radio telephony. The Canadian inventor of radio telephony. So this guy has the big first, not Tesla and not Marconi, unfortunately. I say Marconi, unfortunately, because most people think Marconi invented radio, but that's not really. I mean, it's not that simple. And Fessenden was not the only guy either. I mean, there was a group of people, scientists, working on it. Now, Fessenden, like Tesla, was a scientist, whereas Marconi was much more of a doer. Here's some more. He wanted to make the business happen. I'm pretty sure. There's Marconi right there in the middle. What happened was that Marconi knew how to raise interest in what he was doing. There's a picture of Professor Fessenden working in his laboratory. Look, check out what he's got there. First, he got a cigar hanging out of his mouth. Well, he's got various coils all around him, and he's got a book open. Yeah, Mr. Fessenden, Professor Fessenden. Yeah, so this is Fessenden's shop with his guys. It says early wireless telegraphy. Note wires strung everywhere compared to Fessenden's orderliness. Yeah, really. The wires everywhere. It looks pretty orderly. This looks more like wires everywhere to me. Maybe the writer of this book had some great interest in sort of promoting Fessenden, which I think is a worthy thing. So there's the famous Canadian side of the cross, sending a signal across the Atlantic Ocean, which was a huge breakthrough done by Marconi from somewhere in Scotland, somewhere over there to here. This is, of course, on the east coast of Canada, sticking out in the ocean. So this is the guy. The reason I'm dwelling on this, Fessenden. You might want to read up on this guy a little more. He also invented television. What? Yes, and it's a name you probably never heard. What a shame. What a shame. He had to go, like so many Canadians, he had to go to the United States. Would you believe Marconi came from Italy, got the Canadian government interested in his experiments, and the Canadian government funded Marconi. Fessenden, at the same time, was putting forward his applications for government support. I mean, these guys had to get money from somewhere, right? They don't have money to start. And the Canadian government was not interested. So guess what? He went to the States. Yeah. Man alive. Man alive. Okay, now we're ready to get back to doing what we were doing here. We're doing the battery experiment to demonstrate capacitor that becomes a battery. Look at all these batteries I have. Holy smokes! Time for those to go in the garbage, I think. Who's next on this chassis? Who am I gonna go after? So I think one that is kind of attractive to me is a capacitor located right in here. It's all around these coils, so it's kind of in the front end. Pretty sure it'd be in the front end of the radio, and that'll be the last one that's kind of in this section of the radio. We can guess this is more the output section of the radio here, audio and end of the IF type stuff. So why don't we go after this one right here? Let's find out first. Who is he? What's he doing in there? Is he hiding? Is that why he's in there? Okay, this goes this way. Looks like this one right here. What a wonderful diagram this is. This is part number 3. Condenser, 0.03 microfarads. Oh, it's coffee break time already. Holy smokes. How do you like that? 0.03. Yep, that's a 3. And it's number 3. Number 3. Surely I can't get confused by 2 3s, can I? Where is capacitor number 3? There he is there. Oh my gosh, look what he's doing here. So this line, if you follow it back, goes through a large resistor, then meets up with, oh my gosh, what does it meet up with? Wait a minute, this isn't quite what I expected. Let's start the other way. So this is the detector. So they're using a triode here. They're using the triode as the detector. I believe that's what's happening here. Yeah, that's what it says right there. So it's not a question of belief. I can read. Okay, so it's just not normal to find a triode in a detector position, but not really any consequence, I suppose. So, okay, so this is rectifying. The output can be found maybe here, maybe here. If we come down here, there's capacitors. That would let the audio signal through. Oh, there's a ground right there. So that's not what's going on here. So this little capacitor here, 100 picofarad capacitor, to ground is trying to provide sorry, a signal ground right at the bottom of this coil. If no DC can get through here, the rectifier will generate some DC. That will flow this away. And there's a ground. Okay, I wasn't expecting that. Come on. This is okay. Let's go back to this line. So now we know that this is actually a diode, being used as a detector, or triode being used like a diode or a detector. Huh. Man alive. So down here is coming a DC voltage from the rectifying action here. Still true what I said over there. This is all to recover the audio. This whole circuit area here. Whereas this is bringing bringing the rectified DC down here. There should be a capacitor involved here somewhere, not just over here. Shouldn't there be one on this line? Should it be that guy? It's a small one. I don't know what that little guy's doing there. This arrangement's just not quite what I'm familiar with. Well, I would have thought there'd be a capacitor sitting right in here, but there is not. So we've got a unfiltered output from here, unless somehow if filtering's occurring here, such that there's... Jim, what are you talking about? I don't even know anymore. What am I talking about? Okay, keep pointing with your pinky though. Okay, so through some magical process I'm unable to explain, DC voltage is created here, which works as the AVC voltage. So if we follow this line up, it goes through the coil and makes it to the grid. We follow this one over, through this coil, makes it to the signal grid. That's the AVC action happening there. So back to the capacitor I'm going after. Remember that thing? Number 3? This is 0.05. Well, it really looks like a 3 to me. But let me take a closer look at it. 3. So it's a 3 on the sheet. 5 on the schematic. Now that's twice this has happened, where the parts list doesn't match the schematic. Okay. not to sweat over it, we're going to take the capacitor out. I bet you it is a 0.05. That's very commonly the size you find here. This acts like a bucket. So some charge can make it through here, fill up the bucket a bit. And if the charge wants to go the other way, the bucket will slowly come out. So this has a damping effect on the DC voltage variations that may be occurring. So if the radio signal is fading in and out, it have to be fairly rapidly too. It couldn't be a really slow fade, but if it was fading fairly quickly, this voltage wouldn't follow it. It wouldn't follow the fast fade. It might follow a fade this fast though. Hey, I'm talking a lot, not doing much today. So okay, we know what it is. Now what would happen if that capacitance was gone? The AVC if there was no capacitance there, if I cut that capacitor away and operate the set, probably get two effects. One is the AVC voltage would become very fast. Could very well end up with a feedback situation going on. And what am I doing here? I'm all out of sorts today. I know what it was. I was up late last night doing astronomy. And that's why I'm a little cockeyed today. So this is the terminal. Yeah, so if this capacitor is very leaky, and even a little leaky, in this position, the leak could have a strong effect on the radio. Now, what would it do? It would lower the negativity of the grid. Well, okay, can I get a cutter back in here? Oh, it's an easy target to cut the wrong wire there. I may have to abandon this capacitor in here. Just leave it cut on one end. That's not the best thing. That's like a little antenna then. Good. Okay, so I was able to bend the wire and recognize which wire it is over here. See if I can cut it. I don't think so. I need a better set of cutters here. Shoving it into, there's lots of fine wires in this area of the radio, and I'm shoving this capacitor into them. I gotta poke up the wire here. Poke it up so I can get the cutter around it. Yeah, now we got it. Okay, now that's a ground terminal there. Very good. Put this other way, the clip fell off. The other thing I do when I cut these capacitors free is I leave a little tidbit of wire. And I can spot the tidbit and know that's where the capacitor came from. That's the theory anyway. Okay, now get this out of here. Like a game of Plinko here. Here he comes. Is it a 0.03 or 0.05? 0.05. So if this guy's leaking a little bit, because the circuit he's in is a high impedance circuit, it's got grids going nowhere at one end in tubes, and the other direction he's facing a 1,000,000 ohm resistor. So that 1,000,000 ohm resistor doesn't allow refilling of the bucket, not quickly. So this guy could drain the bucket. He is the bucket. It's like the bucket has a hole in it. Small hole, no problem, because the incoming flow is significant compared to the outgoing leak. Bigger leak, the bucket is going to go down. Okay, happen to have. That was interesting. I'm just resetting my tripod here. Get a better look at the guy. Okay, he's hooked up. 50 volts. Are you ready? Well, it looks good. 50 volts looks good. How about 150? Can't do it. A normal operation, this capacitor is facing 10, 15 volts, not much more than that. Could this thing be leaky enough to disturb the automatic level control or automatic volume control? That's a good question. I don't know. I don't know. How can you know, really? You replace it and see that the radio operates differently, but you'd have to take some steps to enable you to recognize a change like that. It'd be a little bit tricky in some cases. So 0.05 has got to go in there. Oh my gosh, look what I've got for, yeah, 0.05. Okay, I got to go hunting. My 0.05s are a little low here. You have to hunt, and it's a low voltage deal, so I'm sure I've got one. 0.05. Well, that took a long time. The little capacitor back in here. Actually, it's two in parallel to get the right amount, the right value of capacitance there. Time to test the radio and see how well it works. So it's on. There we go. Have an antenna connected. Here we go. What band are we on? We'll start on the shortwave band. My antenna is probably not suitable at all for broadcast or AM radio. So let's try shortwave. That's how that ends. We should be up around 9 megahertz. That's right where I'm pointing here to hear something. Let's see, we got 80 volts. Let's give it the full deal. That's full volume. Not very impressive yet. Okay. Can we find that signal at 9.3? Doesn't look like it. Nobody home. So the sun is doing funny things, but
with mercy,
there it is.
Lack of rain is a gentle persuasion to turn to Yahweh and worship Him.
As on the wrong side of 9.
Turn back now to Isaiah 65 and read verses 1 and 2. Just 1 second.
So it's a lot of nothing here in the volume control. You gotta get up pretty high.
Did not ask for me. I was found by those who did not seek me. I said, here I am.
I was found by those who did not seek me. Okay, that's it for today. One capacitor is all I'm going to do. Fantastic though. We continue along one step at a time. What do we got left here in terms of capacitors? We've got 1, 2. Probably should do this one here. This is probably the grid blocker, which proved to be functioning, but probably a good time to get rid of that one too. That's got to be an earlier replacement by a previous repair guy. Still don't know what this thing is in the middle here. Now perhaps someone has made a comment about that on one of the videos, and you might be wondering, well, why don't I know now? Because somebody put a comment on the video. I don't read the comments. Right? I'm not going to go into details as to why, but I don't. As a matter of practice, I don't read the comments. So there we go. That's good. A couple more capacitors, and then we're on to the alignment, and perhaps even done at that point with this radio. Fantastic. Thanks a lot for watching, and I'm off to have a beautiful day. It's beautiful outside. It's not that hot. Sunny. Fantastic. That's where I'm going. See ya.